Hello, I'm Mary, and this is another magical math moment. I thought it would be fun to give you all a nice little quadratic word problem to get your brain thinking here. So follow along with me as I kind of pull this problem apart with you. A ball is kicked from a height of 2 feet. It reaches a maximum height of 40 feet after traveling 35 feet horizontally from where it was kicked. The ball is caught 68.5 feet from where it was kicked. What is the height of the ball when it is caught? Okay, so there's a lot going on in here. There's a lot of words, and for me, I know it helps me to kind of see a picture of what's going on here. So I'm going to go ahead and draw my little axes. I know you can't see that, but we're going to scoot it in a minute. A ball is kicked from a height of 2 feet. So that is the initial height of the ball. That's a y-intercept. So on my y-axis, I could put 2 over here. It reaches a maximum height of 40. Again, that's going to be up this way, after going 35 feet horizontally. So around here somewhere maybe? Okay. All right. The ball is caught 68.5 feet from where it was kicked. So we're going to kind of just ignore that for a minute here. Let's label our axes. This is the height of the ball in feet. And of course this is the horizontal distance, also in feet. So it's always good to label that stuff. So if we do a quick graph of this thing, I know 0, 2 is my y-intercept. I've got a max up here at 3540. And remember, there's that symmetry. So if this distance over this way is 35, I'm going to go another bit of it over here. So from this 35 to over here, another 35 is going to end me up over at 70. Now, a lot of the problems we do actually involve the origin at an x-intercept. That's not happening in this one. It's a little bit strange. So we're going to do just like a little quick sketch here. Oh my gosh, that's pretty hideous, but you get the general idea. Now, this problem is different because it wants to know the height of the ball when it's caught 68.5 feet from where it was kicked. So if it was kicked over here, 68.5 is going to be real close to the 70. So we're just going to go up, and that's the y value that we're trying to find. So this is the point 68.5 something. That's what we're being asked to figure out. Okay, this is a lot of information. So let's also label our vertex, so that kind of helps us a little as we're trying to figure this stuff out. I have a vertex and I have a couple of points, so I can use vertex form to assist me in getting the equation. Let's see, y is a times the quantity x minus h squared plus k. I thought it would be fun maybe to use this point over here. This is the point 72. This is an xy point, so I'm going to substitute those values in over here. Y is 2. I'm trying to figure out what a is. X is 70. The h value is the x value of the vertex, so we got minus 35 in here. The k is the y value, plus 40 at the end. Okay. After we substitute, we do a little bit of algebra stuff. So we got minus 40 on both sides. We got negative 38 over here. I've got 70 minus 35. That's going to give me 35 squared times a. Oh, I don't like the look of this already. Let's see if we can get it. Oh my goodness, what's going on? So I've got 35 squared, 1225. Okay, negative 38 is 1225a. I'm trying to figure out what this a value is, so I'm just going to divide both sides easily by that 1225. Let's see what happens. I don't predict it's going to be anything nice. Nope, that's gross. Math, enter, enter. We'll put it in reduced fraction form, and look at that. It doesn't reduce. So I now have this disgusting looking a value of negative 38 over 1225, and I've got to use that to help with an equation. Okay. Ugh, I might need a minute here. Scoot this up so you can see what I'm doing. Okay. We're going to go ahead and throw our a value in, negative 38 over 1225. we have our quantity x minus 35, oh, that's a weird looking 3, squared plus 40. So that is the function I'm dealing with. Now, they want to know what's going on when x is 68.5. So if you just replace this x with a 68.5, you can calculate the value. Let's see if we can figure that out. I've already got this in here, so I'm just going to go times like that. The calculator is going to pull the value down. In the parentheses, I have 68.5 minus 35, which I square, plus 40 at the end. 5.18. So y is approximately 5.2 feet. Okay, that's kind of exciting. If you wanted to look at this in the calculator, you can also do that. So we'll go to y equals. We're going to throw this whole thing in. Don't forget, when you're dealing with fractions, you want to put them in parentheses. X minus 35 squared plus 40. Normally I go to zoom 6, but I know that I'm not going to really be able to see what's going on here, right? It doesn't really show me much of the graph. It's just this piece over here. I can use my quick sketch to help me establish a better window. So I'm fine with x min being negative 10, but I want to be able to see past the 70. So what if I change x max to 80, and we're going to change that scale to 10. Similarly, y min at negative 10 is fine. My max value is 40, so I want to go a little bit above that, maybe 60, and we'll change the scale to 10. That means every tick mark you see is going to be 10 instead of 1. I hit graph, and look at that. It's a pretty nice looking picture. If I want to go into the table, I can do that. There's a couple of things you can do with the table. Normally when you go in, I spoiled the surprise. Normally it starts at like 0, and then you would have to like scroll down for like forever to get to the other side. Another little trick you can use is second window. This is table setup. So you can go right down here to independent, those are x values, switch it over to ask. Once you do that, you go back to your table and you can type in any x values that you want. So I want to know what's going on at 68.5, 5.18, 5.2, which is exactly what we got before. So lots of different ways to solve these things. I thought this would be a nice little example for you to study for your little quadratics test tomorrow. I hope that this has been helpful for you, and I look forward to seeing you again for another magical math moment. Thanks for watching.